Hi, and welcome to High School Physics Explained. My name is Paul, and in today's lesson we're looking at experiment 6.1 in the High School Physics textbook, which has the aim of to measure a magnetic force on a current balance to find the magnetic field strength in a solenoid, which is looking at the motor effect. My Archian hypothesis for this experiment were fairly simple, but explored each facet of the assessment and how it related to the motor effect. My hypothesis basically stated that due to the motor effect, the force exerted by the field will be able to be found by calculating. The results table makes sure to include units for each of the data points found to ensure ease of access. E notation is used instead of times 10 multiplication, as it is easier to input in an Apple standard table and represents the same thing. Interestingly, talking about the results, the current in the solenoid is consistent between each of the trials for both weights 1 and 2. The current element current, however, varies slightly, and each trial having one outlier, being 0.36 amps and 0.36 amps in weight 1 and 2 respectively. Otherwise, the ampere measurement is very similar. This is the working for the magnetic field and the magnetic force. An important thing to note is even though I showed the full trials for the first weight, even though two of them had the same result, I wanted to show the full working of the assignment. Weight 2 I did not, as each of them had the same amp meter for the current from the solenoid, so I did not feel the need to show it because I did it on the first one. The accuracy of my data was something we needed to take careful consideration into, considering the reliability, validity, accuracy, and the uncertainties of the data and how they interplay together in the ending results. Talking about the reliability, considering the equations F equals LIB sine theta and B equals the permeability of free space times Ni divided by L is an important concept, as without these equations you will only be talking about the data qualitatively, not quantitatively, which does not go over the marking criteria. Another important idea to note is to check the data and calculations found. To do this, rearranging the equation for motor effect to find B as the subject helps us test. And here I did two examples of that, showing that my data was reliable and in fact did the calculations correctly. Analysing and understanding the uncertainties in measurements in an experiment is also a critical idea, as without it, your data may not be fully reliable or considered as such. The few main uncertainties in this experiment were the zero error and the human error of measuring itself. These measurements usually came by the ruler measuring the length of the wire and the solenoid, as well as checking the ammeter to find the ampere measurements for the currents in the solenoid and the current element. Another issue with this was that we had to wait until the ammeter showed a consistent current, as the needle was going back and forth, especially with the faulty alligator clip into the current. The main physics ideas looked at in this experiment were the idea of charged particles in uniform magnetic fields, the acceleration and velocity in a magnetic field, gravitational fields created by mass acting on mass in the magnetic field itself, thinking about the motor effect, the fact that current is a quantity of charge per unit time past a point, thinking about torque of gravity onto the current balance, and the motor effect itself, F equals LIB. In conclusion, my original hypothesis was backed up by my results, as the motor effect, which is the force of the magnetic field, could be found through the field strength itself. A relationship was established through this and tested by rearranging a formula, and the values were found for both, showing the motor effect. Anyway, that is it for today's video. Please make sure you smash like and subscribe, and we'll come back next week for a video on the exact same thing, because I don't know what I'm doing anymore, and it's late at night, and I'm very, very tired. Thanks. I've been Paul, and this is High School Physics Explained.